All right, so this is 2B.1 Part A, example number 6. So on 2B Part 1, example number 6, we have the total number of views for a popular podcast is increasing. The table shows the estimates of the total views each month since January 2010. Okay, and we're going to determine what is the best model for this. And the way we're going to do that is by putting it in and analyzing their R-squared values. So that's our plan of action that's going to take place here. So I'm going to grab my calculator. I'm going to reset Sylvie. Second, plus 712. Please ignore the background. I asked you guys to be quiet while I was doing this and work on your do now, but you guys are doing what you do and ignoring me. So if you can't hear this clearly, thank yourselves later. So we're going to go stat. Sorry, before I get started, I'm going to mode and I'm going to turn on my diagnostics. So all right, so I'm going to stat diagnostics, turn it on. And now I'm going to go to stat edit and input the data. So we have 1, 6, 14, 25, 27, 1, 33, 38, 42. And then my Y values, 2/10, 500ths, 1 and 1/10, 2 and 9/10, 3 and 8/10, 8 and 2/10, 9 and 3/10, 10 and 6/10, and 15 and 7/10. So I put in all of the data points are put in. We're going to test for quadratic, exponential, and a power model, okay? So the reason why we're doing that is if we go, turn on our lights, go up to plot, I'm going to go to zoom 9, we can see that the data is increasing and is concaved up. So we're looking at functions that will cause that kind of behavior. As x goes to positive infinity, y also goes to positive infinity at a curve, at a concave situation. So we're going to start with quadratic. So with our quadratic, stat, calc, and we're going to run the quadratic model. So we have 5. You can store it if you want, so that you can, in case you need to come back to it. I like to store it bars, y bars, 1, and I'm going to store it as y. And enter. It's going to calculate, and here's the quadratic that I get. So, and the R-squared value. So I'm going to write the quadratic model. So for the quadratic model, we have y equals 0.013 x squared minus 0.205x plus 0.843. And the R squared equals around 4 decimal places, 0.9698. Okay, so that one's done. And now we're going to do the next one. So I'm now going to run an exponential. So stat, calc. I'm going to go to exponential. I have to scroll down for it. It's actually 0. So hit exponential. This time I'm going to store it. Bars, y bars, 1. It's going to be my second y equation. I'm going to hit calculate. And here are the values that I get. Remember, exponential is a times b to the x power. So my a and my b, and I'm going to write those out. So we have, and y equals 0.23, I'm going to go 86, 1.1099 to the x, and the r squared here equals 0.985. Okay. All right. Now we're going to do the power model. So our power model is what we have left. So to stat calc, and I'm going to scroll down. Oh, there we go. Power, and enter. And I'm going to store it. So bars, y bars, 1, and this is my third equation, and enter. So for power, we end up with these values. The difference with a power and exponential is that the power is telling you what is the best power, like quadratic, square, things of that nature. Whereas exponential, your variable is the power, remember? So these are our values. So we're going to write it out. So we have y at 115 x the 1.1547, and it's going to be r squared equals 0.8771. Okay, so looking at what we have here, we can determine that out of the options that we have, the best model would be our exponential model, and that's because it has the r squared that is closest to 1. So the best model would be exponential. Okay. We're going to go look at our equations. So I'm going to go to Zoom. I'm going to go 9. And when you look at the graph, the first one that it's going to graph out is going to be the quadratic. So here's our quadratic model. Not bad. Next is going to be our exponential model. No, Sylvie goes a little slow, but there's the exponential model. And then last but not least is the power model. And the power is just basically almost a linear, because look at what the power is, 1.15, right? Almost linear. And that one's why it was so low as far as your r squared. And we can see now how and why, based on what we have, what is the best model. Okay. The other thing is we can analyze their residuals. In order to do that, we would have to, we would have to delete one at a time. In my understanding, I'm going to test this out with you guys because I've never done residuals with more than one graph given at a time. But certain stat 7, and I'm assuming that it's going to be very interesting to see how this plays out. I think it's for the quadratic. I'm going to say it's for the quadratic. But if I was to do it individually and check out the points, how would they look and what would describe? I'm going to write it out for you guys. So for the quadratic, the residual graph would be random. So it would be randomly scattered. Okay. For the exponential, it would also be randomly scattered. And a good thing that shows us that is looking at our r squared values. Remember, our r squared values were fairly close in those two. And then, however, for the power, if we were to look at the residuals for the power, it would have been concave up and in an increasing behavior. And that's just letting us know that it obviously isn't a power, or the power isn't the best model for it. Okay. So based on our findings all together in total, we can say that the exponential model is the best model. So we know that exponential model, I don't know why. Maybe it's the computer, is the best model. is the best model. And that's because since the R squared value approximately was 9,805 10 thousandths. No. Yeah, 10 thousandths. 10 thousandths. And the residuals, your error and residual are randomly scattered. Scattered. Along the horizontal axis. Okay. And then last, using chosen model, what is the expected number of the views in 5 years? So if we were to do that, that's why I said it was good to store it, because if they ask you additional questions, you already have your graph stored. So if I'm looking for the views in 5 years using exponential, remember the exponential was our second. So we're going to look at y2. So we're going to go look at our y2 on our table and find the value for 5. So here, I'm going to go to my table. I'm looking for the value of 5. And because y2 is our best option, we can go over and we can see what that value would be for the graph. And, oh, it said 5 years. 5 years is 60 months, guys. 5 years, sorry, not 5 months. It's in terms of months, and we need to find out how many it's going to be in 5 years. So we need to go all the way down to 60. If I didn't want to scroll all the way down to 60, that's where we use our table settings. So second window, and I just want to go to 60. So I'm going to type in 60, like start at 60 for me. And when I go there, I can see, okay, for Y2. So according to our Y2, it would be about 124.61. So 124.61 million views. So in 5 years, then and therefore, after analyzing all that, we would say in 5 years, sorry, y'all are getting loud, about 125 million views using exponential model views predicted. Okay. All right. That would be 6.